We live inside a galaxy so massive, so ancient, that we've never truly seen it. Not from above, not from the outside. But for now, for the first time, scientists have uncovered the most detailed map of the Milky Way ever created. Hidden waves of gas, ghostly black holes, and galactic collisions that may have triggered the birth of our Sun. This isn't just a new image, it's a window into the secrets of our cosmic home. Imagine standing inside a forest so dense, so endless, that no matter where you look, all you see are trees. You know you're surrounded by something vast, but you can't see its shape, its true form remains hidden. That's exactly our situation inside the Milky Way. We're part of it, just one tiny speck spinning through one of its spiral arms, and yet, for centuries, we've tried to understand what this gigantic star-filled structure really looks like. The problem? We can't just step outside and take a picture. The galaxy is over 100,000 light-years wide, that's nearly 600 trillion miles across. If we launched a spacecraft today and pointed it toward the edge of the galaxy, it would still be flying for millions of generations before getting there. So how do we know what the Milky Way looks like? The answer is as ingenious as it is mind-blowing. Scientists have built a map, not by taking one photo, but by stitching together the positions and movements of billions of stars piece by piece, like assembling a cosmic puzzle. And at the heart of this monumental effort is a spacecraft called Gaia. Over the last decade, Gaia has quietly scanned the sky every hour, every night, collecting data with incredible precision. Not just of stars, but of their motion, their distance, their light, and even their chemical fingerprints. Thanks to Gaia, we now have something we never had before, a three-dimensional, moving map of our galaxy. And what it reveals is stunning. So, how do you map something you can't see? Something so massive it would take light, the fastest thing in the universe, over 100,000 years to cross? The answer begins with a satellite orbiting quietly a million miles from Earth, a machine designed not to take photographs, but to watch the stars move, to measure their tiny shifts in position, their colors, their brightness, even their motion through time. Its name is Gaia. Launched by the European Space Agency in December 2013, Gaia is humanity's most ambitious attempt to understand our place in the galaxy. But Gaia didn't come out of nowhere. It was built on the legacy of an earlier mission, Hipparcos, launched in 1989. That spacecraft mapped around 120,000 stars, a stunning achievement back then. But Gaia? Gaia aimed higher, much higher. Its goal was to chart the precise position and motion of over 1 billion stars. Not just where they are, but where they're going. That's about 1% of the entire galaxy. You see, Gaia doesn't orbit Earth like the Hubble Space Telescope. Instead, it sits in a gravitational sweet spot known as the L2 Lagrange point, far beyond the Moon, a place where sunlight, Earth's gravity, and orbital mechanics balance perfectly. This spot allows Gaia to remain incredibly stable. No shaking, no atmospheric interference, just crystal clear space. But what truly makes Gaia special isn't where it is, it's what it can do. Gaia can measure the position of a star with such precision, it's like spotting a coin on the Moon from Earth. And it can do this not for one star, but for billions, every single day. It quietly scans the sky in a slow, methodical spin, tracking each star's subtle wobble, color, brightness, and speed. Bit by bit, it collects the puzzle pieces that, when assembled, give us the clearest map of our galaxy we've ever seen. But Gaia isn't just measuring stars for fun. It's revealing the architecture of the Milky Way, the invisible structures holding it together, and even the hidden forces shaping its evolution. What started as a space telescope has become a cosmic time machine, one that looks not just at where stars are, but where they came from and where they're heading. But here's the real question. How does Gaia do all this? How can a machine 1,000,000 miles away see stars shift by just a fraction of a pixel and turn that into a map of the galaxy? The answer is a masterpiece of engineering, and what you're about to hear next will blow your mind. Imagine trying to track the position of a firefly from 1,000 kilometers away. Now imagine doing that for 2 billion fireflies, all moving in different directions across the entire sky. That's what Gaia is doing, every second. But how? How can a machine floating in space measure the tiniest shifts in stars that are light years away? The secret is in its design. At the heart of Gaia are 2 identical telescopes angled precisely 106.5 degrees apart. This setup allows Gaia to use a technique called triangulation, measuring a star from 2 perspectives to calculate its exact distance. The light that enters Gaia is then reflected and focused by a set of ultra-polished mirrors onto a gigantic camera array, the largest ever flown in space. It's made up of 106 CCD detectors with nearly 1 billion pixels, and each pixel is used not to take a pretty picture, but to measure movement down to millionths of a degree. As stars move across Gaia's field of view, they pass through 3 layers of analysis. First, the astrometric CCDs, which track their precise position and tiny motions over time. Then, the photometric CCDs, which use tiny prisms to split their light, revealing the star's brightness, temperature, and even its chemical makeup. And finally, for a portion of stars, the light hits the radical velocity spectrometer, which tells us whether that star is moving toward us or away from us, thanks to the Doppler effect. Now here's where it gets wild. Gaia doesn't focus on one star at a time, like traditional telescopes. Instead, it rotates continuously, scanning the entire sky in a complex pattern that ensures every star is observed multiple times from different angles over many years. This repetitive observation is what lets Gaia create not just a snapshot, but a dynamic, evolving 3D map of our galaxy. On average, it scans more than 2 million stars per hour, generating over 50 gigabytes of data per day, all of it beamed back to Earth for analysis. And behind every pixel, behind every flicker of light Gaia detects, there's a story, a journey, a star with a past and a future. Piece by piece, Gaia is revealing not just where stars are, but how they move and even why they move. And that movement, that's where things get truly fascinating. Because when you put all that stellar motion together, the Milky Way doesn't look like a calm, orderly spiral anymore. It begins to twist, to ripple, to breathe, like something alive. And what Gaia found in that motion changed everything. We often imagine space as still, silent, frozen in time. But Gaia has revealed something very different. The Milky Way is alive. Every single star is moving, spinning, drifting, falling, rising. Some travel in graceful circular paths, others shoot off like sparks, breaking the rules. Our galaxy is not a static postcard. It's a swirling, breathing storm of stars, gas, and invisible forces. And Gaia, by tracking each star's position over and over again, has turned those tiny shifts into something extraordinary. A time-lapse of the galaxy itself. Let's take our own sun, for example. It's not sitting still. It's hurtling through the galaxy at 828,000 kilometers per hour, dragging the solar system along with it like a comet's tail. At that speed, it still takes over 200 million years to complete just one orbit around the galactic center. Gaia has mapped the motions of millions of stars around us, and when scientists played that motion forward and backward through time, they saw something breathtaking. Constellations melting and reforming, streams of stars winding through the galactic disk like rivers, clusters exploding outward from ancient collisions. Some stars move smoothly, following the galaxy's rotation. Others behave like rebels, flying above and below the disk or spiraling inward from the edges. But these aren't just random patterns. When Gaia's data is visualized in 3D, the Milky Way looks alive, as if the entire structure is rippling, twisting, dancing through space. In fact, we know that the galaxy itself is not flat. It's warped like a vinyl record left out in the sun, bending and wobbling as it spins. And that warp isn't stable. It moves, it pulses, it changes shape over time like a spinning top starting to tilt. The big question is, why? What force is twisting the galaxy's disk like that? Is it gravity from something unseen? A hidden satellite galaxy? Or something else entirely? The deeper we look into the Milky Way's motion, the more we realized this galaxy has secrets, and some of them are buried in waves of gas thousands of light years long, structures we didn't even know existed, until Gaia revealed them. For decades, our vision of the Milky Way was based on models, best guesses stitched together from incomplete data. We thought we had the general shape figured out: a glowing central bulge, two grand spiral arms, and a flat disk. But Gaia has shattered that illusion. What it revealed is far more complex and far more beautiful. First, those spiral arms? There aren't just two. Gaia's map shows several arms, some faint, some twisted, some not even symmetrical. The structure is messier and richer than anyone imagined, like a whirlpool caught mid-spin. Then there's the galaxy's shape. The Milky Way's disk, the vast star-filled plain we call home, isn't a flat sheet. It's warped and rippling like a flag in the wind. And here's the kicker: that warp is moving. Over time, it shifts, not randomly, but with a kind of rhythm. Some researchers now believe that something massive, maybe a dwarf galaxy or a dark matter clump, is pulling on us, disturbing the disk from the outside. But Gaia's most jaw-dropping discovery? A colossal wave of gas, invisible until now, flowing through our part of the galaxy like a ripple through water. It's called the Radcliffe Wave. Nearly 9,000 light-years long, this undulating ribbon of hydrogen gas stretches across the Orion Arm, the same spiral arm our Sun is in. Before Gaia, it appeared only as scattered pockets of star formation, isolated but unrelated. But Gaia's 3D map connected the dots. And here's what's truly eerie: our Sun is riding right along the edge of this wave. Scientists believe it crossed the Radcliffe Wave about 13 million years ago and will do so again in the future. Almost as if the solar system is surfing a galactic tide. But what caused this massive wave? No one knows for sure. One theory suggests that a cosmic collision, possibly with a rogue dwarf galaxy, sent shockwaves through the Milky Way's disk, bending it like ripples in a pond. And this may not be just a beautiful curiosity. These waves of gas are stellar nurseries, places where stars are born, which means that something that happened millions of years ago might have helped spark the birth of new worlds, possibly even ours. Because as strange as that sounds, it gets even wilder. What if I told you the Milky Way has been in repeated collisions with other galaxies? And that one of those collisions may have helped create our Sun? What if I told you our galaxy is not the peaceful, graceful spiral we once believed? In reality, the Milky Way is a cosmic predator, and for billions of years, it's been devouring smaller galaxies. One of the most important victims? The Sagittarius Dwarf Galaxy, a tiny, ancient system that's been circling and crashing into the Milky Way like a moth into flame. Gaia's data revealed something astonishing. The Sagittarius Dwarf Galaxy didn't just collide once. It's hit the Milky Way at least 3 times, around 6, 2, and 1 billion years ago. And with each impact, it sent ripples through the galactic disk, gravitational shock waves that stirred up clouds of gas and triggered waves of star formation. Like throwing a rock into still water, those ripples spread far and wide. One of them may have reached our corner of the galaxy about 4.6 billion years ago, right when the Sun and our solar system was being born. Let that sink in. The stars we see at night, the planets we walk on, maybe even life itself, could all be the result of a galactic crash. But this story doesn't end with destruction. As Sagittarius passed through the Milky Way's disk again and again, it left trails of stars behind, like breadcrumbs marking its path. Gaia tracked these stellar remnants, great arcs of light curving through space, and traced them back to their origin. They're the shattered bones of a galaxy being consumed. With every orbit, the Sagittarius dwarf galaxy becomes smaller and weaker. Eventually, it will be absorbed entirely, a forgotten ghost swallowed by the spiral it once danced with. But its impact? Permanent. It reshaped the Milky Way's structure, reignited star formation, and quite possibly gave birth to our home. And the Milky Way's appetite isn't over. In a few billion years, it will collide with Andromeda, our neighboring galaxy, in a galactic merger of unimaginable scale. Gaia won't be around to see that, but it has already shown us something profound. Our galaxy is a product of chaos, and we are the children of that chaos. And while Gaia helped us uncover the past, it's also uncovered things we never expected to find. Strange objects, hidden forces, and even celestial bodies we didn't believe were possible until now. At first, Gaia was designed with a simple goal: map the stars. But the universe had bigger plans. As Gaia scanned deeper into space, its instruments began to reveal more than just distant suns. Hidden among the starlight were secrets no one expected to find. One of Gaia's most surprising contributions has been right here in our own solar system. It's mapped the orbits of over 150,000 asteroids with incredible accuracy, including many we never tracked properly before. But what's truly fascinating is what Gaia discovered about some of them. A number of these asteroids show tiny rhythmic wobbles in their paths, and that wobble? It suggests they're not alone. Gaia uncovered asteroid pairs, small moons orbiting these space rocks, dancing around them in perfect sync. Until now, most of them were completely invisible, and the surprises didn't stop there. Gaia also revealed something far darker and far more mysterious: sleeping black holes. Unlike the blazing, devouring black holes we usually hear about, these are silent, invisible. They emit no light, no X-rays, nothing. But Gaia found them anyway by detecting their gravitational pull on nearby stars. These stars wobble unnaturally, as if tugged by an unseen hand. So far, Gaia has helped confirm the existence of 3 of these hidden monsters named Gaia BH1, BH2, and BH3. The last one, BH3, is particularly strange. It's the most massive stellar origin black hole ever found in our galaxy, with a mass 33 times greater than the Sun. And it's not even that far away, just under 2,000 light years from Earth. Cosmically speaking, it's right next door. But perhaps the most unexpected discovery is the detection of new worlds. Using its incredible precision, Gaia was able to spot subtle gravitational tugs on stars, signs of orbiting objects we couldn't see directly. One of those is Gaia 4b, a super Jupiter nearly 12 times the size of our largest planet. Another is Gaia 5b, a rare brown dwarf orbiting a faint, low-mass star. Both of these objects challenge what we thought we knew about planetary formation. They're oddballs, massive, rare, and hard to explain. And yet, Gaia found them, quietly, elegantly, with nothing more than light, motion, and time. But here's the thing. As mind-blowing as all of this already is, Gaia's mission isn't over. In fact, the most detailed revelations might still be coming, because the best is yet to be seen. In just over a decade, Gaia has completely transformed the way we see the Milky Way. It's turned stars into stories, and darkness into data. But here's the most exciting part. We're still only scratching the surface. 2 massive data releases are coming, one in 2026 and another in 2030. Each one will sharpen the map, reveal new objects, and maybe answer some of the biggest questions we've ever asked. What is shaping our galaxy's strange movements? Are there hidden forces at play? Could something, or someone, be out there, beyond what we can see? With Gaia, the unknown is getting smaller, but the mystery? It's only growing. And if this is what we've learned from just one telescope, imagine what's still waiting in the stars. If this journey blew your mind, you haven't seen anything yet. In the next video, we dive into mysteries beyond the Milky Way and what they might be hiding. So hit subscribe, turn on the bell, and prepare to see the universe like never before. Because this is just the beginning.